PCB etching is the process of removing unwanted copper to reveal the desired circuit pattern. In this video, we will demonstrate how PCB etching are performed safely and effectively. To begin, the following materials are required. First is the copper-clad board. Next is printed circuit design on photo paper or glossy paper. It is important to note that the circuit design must be printed using laser printer, not inkjet printer, as the laser printer uses toner or powder plastic that is heat meltable and sticks to a copper when ironed. Steel wool, or you can use the rough side of your sponge, and water. Some tweezers or handling materials, flat iron or the iron that we use in clothing. We can actually use hair straightener as well. And lastly, paper towels. Before etching, the PCB is trimmed to the desired dimension. This process is also known as PCB edging. The sharp edges are smoothed using sandpaper or file to ensure safe handling and proper fitting in the enclosures. After trimming, the copper surface must be prepared before transferring the circuit design. The board is gently cleaned using iron wool or the rough side of the sponge. These steps removes oxidation, dirt, and oils that may prevent proper adhesion of the toner. Let me show you the difference before and after. Once the copper surface is properly cleaned, the circuit design is transferred using the toner transfer method. The printed design is gently preheated. Care must be taken not to overheat, as the goal is only to slightly soften the toner on the photo paper. Next, the flat iron is heated into an appropriate temperature, typically set to high without any steam. The printed design is then aligned and placed on the copper surface of the PCB. Using the heated iron, firm and even pressure is applied while continuously moving the iron across the surface. This ensures uniform heat distribution and proper toner adhesion. The board is typically ironed for about 2 minutes, followed by a short resting period to allow the toner to settle. This process may be repeated to ensure that all areas are properly transferred. To check if the transfer is successful, a small portion of the paper may be carefully lifted using tweezers. If any defects are found, like incomplete or missing areas, they can be corrected by applying nail polish or permanent marker to reinforce the circuit traces before proceeding to the etching process. After ironing, the PCB is allowed to cool, then soak in the water to dissolve the photo paper and reveal the transferred toner. However, if the toner has already fully adhered and the paper can be cleanly removed, the soaking step may be skipped. Before starting the etching process, all materials should be carefully prepared, and the procedure is best performed outdoors or in a well-ventilated area. While wearing protective equipment such as gloves and goggles, as ferric chloride is corrosive and irritating chemical, a plastic container must be used, as the solution can react with and damage metal containers. The PCB is then fully submerged in the ferric chloride solution with the copper side facing downward to allow gravity to aid in the removal of unwanted copper. The container should be gently and continuously agitated to speed up the etching process and ensure uniform result. Submerge the PCB for at least 15 to 20 minutes. Once the excess copper has been fully dissolved, the PCB is removed, thoroughly rinsed with water to stop the reaction, and then dried properly. After etching, prepare acetone or nail polish remover and cotton swab to remove the remaining toner from PCB. Gently rub the surface with cotton, applying enough pressure to ensure all the ink is completely removed. Once cleaned, the PCB is ready for drilling holes according to the size of the pads. Before or after drilling, make sure all component leads and metal surfaces are filed or sanded to remove oxidation, dirt, or oils, ensuring proper adhesion during soldering. That's it for this video. Stay tuned for the next one, where we will cover proper soldering techniques and material assembly. Thank you for watching.